Well, as you can see, it's finished. It's taken 4 months. Who'd have thought it would take 4 months to build a box? Admittedly, it's been a complicated structure, and it was glass fibre, never done that before. Bit more welding, which I'm not good at, as those of you who watch the show will know. And the control panel, yeah, there's a lot going on in this build. Having said that, it's finished, and I'm chuffed to bits. I am really pleased. In fact, I'll show you something. This is the first part to come off the machine, and I'll have to say it looks spot on. It's this is a limit switch. It's a cover for the X-axis limit switch, and I'll show you that in close-up in a second. But more to the point, I must make an apology for this video to start with. I've worked in broadcast for more years than I care to mention. I ran my own business for a while, and I've made well over 100 of these videos. So this is the very first time in my entire career I managed to record an entire show with no audio. Don't ask me how I didn't notice it, but I've been shooting this video for this episode for 2 weeks, and every single shot on my main camera, that one, was mute. Idiot. Unbelievable. Anyway, apologies for that. I'll show you a quick close-up of this box, and join me after the titles and we will watch this thing being finished. You can see there's a hole got to be drilled in the top there for the switch to poke through. Apart from that, and a cable exit, apart from that, that's pretty much done. So if you watched the last episode, you'll know that this mill has fought me all the way to this point, and you see me here putting on the slave cylinder for the power drawbar, and it was a bit of a pain. I had to put there we go. I had to put new O-ring seals in the power piston, which is at the back of the machine, and yeah, I don't know why really. O-rings should last for years and years and years, and that's only been probably 2 years, if that. Anyway, you saw me there just filling it up with hydraulic oil, and here we are pushing the PC back into the back of the cabinet, and that's the power drawbar master cylinder, that big black lump. There you go, that thing. So that hangs off the back here, so that if it gets a leak, it's not a problem. And here we go for a bit of testing. So as you can see, I changed the pipe for one with a right angle on it, and it needed to be a bit longer. So if I press the drawbar button here, and you'll see, you can't hear it, but you can see the tool pops out. Right, so here we go. Next bit of testing. The foot switch is down there, and that other cable is the switch lead. No, that other cable is for the touch probe, which is there. So round the back, the orange cable is for the foot switch. Everything's been rewired up. It's not hugely neat, but yeah, what can I say? It all seems to be there. So the next step, the only thing that's not wired up at the moment is this, which is the oil, the automatic oiler. I've got some more oil to go in there, but I thought it's best to leave that until I've completely finished everything else, because it'll just keep pumping oil into the mill. So the only other loose cable is this one, which is power. So let's plug that in, turn it on, come over to the breaker, turn the breaker on, all that bursts into life. And around the front here, lights have come on. And the PC is booting up. That's good. That all appears to be hunky-dory. There's my mouse. There we go. Right. Reset. Put the machine into CNC. Back over here. Reference all home. Let's try the drawbar. That works. That's flashing. Put that back. Press the button again. Here we go. That works. So I'll try the foot switch. Yeah, tools out. Off the foot switch. Tools in. Spindle can rotate. Let's just try MDI. M3. Speed 2000. There we go. M5. Stop. Perfect. So I have lost flood. That has got to be a switch fault. Everything else seems to work. Oh, let's try this. Make sure that works. Here we go. Yep, can read that. Excellent. Perfect. And if I go to the diagnostics page and pick up my probe, touching my probe on there should cause the digitize to work, which it does. Oh, the other thing is, let's go back to, whoops, go back to program run, start the spindle again. Yep, I'm getting RPM feedback as well. Perfect. So it all works with the exception of flood. Oh, I haven't tested these, have I? Hang on, turn jog on. X, Y, Z, that all works. I decided that I could improve this this chip collection tray. I thought it needed a couple of handles. So those red handles you see on the desk there are old theatrical light handles. So I just marked up where they're going to go and click. There we go. Simple bit of drilling out and then fit these handles. In the end I put one on either side because I thought that would be easier if you're holding it above a bin to empty it. Tap directly. So screw the handles on and jobs are good, as they say. I'm quite pleased with that. I thought that actually worked out quite nicely. Much easier to empty it. And it still fits. Who'd have thought? Right, on with the windows. This took a bit of thinking about, to be perfectly honest, because there, as you can see, there's from the sort of masked off area, there isn't a lot of area to put the screws in, and I had to clear the in the bottom of left hand of the shot. You can see there's some sealing tape, so I needed to clear the sealing tape. I didn't want to put screws through it if I could help it. So yeah, it took a bit of thinking about, and also careful marking out so that the screws look even, you know, the right distance between each one. So I used some dividers here to get it close to. Then off to the jolly old drill press. That's a PCB drill. I find that they're very good for this sort of plastic. Don't ask me why, don't ask me how I ever found out, but they do cut a nice crisp clean hole. So having drilled out all of these holes, which did take a while I have to admit, there's quite a lot of them, back to the machine to refit the window and then use it as a template to drill through from the inside so that you can see exactly where the screws need to go. There you go, on the inside. Drill the little holes and then eventually take this out, open those holes up on the actual cabinet and tap them on the window itself. So there we are, just open the holes out for clearance for M5s. These they're M5 stainless button head screws I used in the end because they were available and they were cheap and I didn't have anything suitable that wouldn't rust. So here we go, power tapping the acrylic. I've found over the years that acrylic is quite forgiving in that respect, but you do have to be careful because it can crack. Ask me how I know. Oh, and this is the most satisfying bit of audio that you'll never get to hear. You'll just have to imagine just how satisfying that sound would have been. So next up was to add the sealing strip. This is, it's a sort of a neoprene type of material, but it's quite soft and squishy. It's for sealing windows, I think. Oddly enough, because that's what I'm using it for. I must rehearse these things, you know. Anyway, that's the window, complete. And we now fit it. There you go. I'm quite pleased with this. When it's in like that, it actually looks really good. It's almost semi-professional, I'd call that. Whilst I've been looking at the doors, I thought this doesn't look quite right. I thought it was in the wrong place. So lo and behold, looking inside, you shouldn't be able to get your finger up behind there. This end should be against this panel. So I need to move both of those. Off camera, I painted the tops of these doors on the inside so they won't scratch off, just to hide the slides, because I thought those slides, they're bloody ugly, to be perfectly honest, so I can do better than that. With the two doors, when they're pulled together to close the cabinet off, there's always going to be a tiny little gap between the two, and that's a clear area for coolant to fly out of. So I cut this piece of acrylic to bridge that gap, so I'm going to stick it, as you'll see, on the back of one of the doors so that it's a barrier for the coolant to come through. I used this glue that I'll show you in a second, this stuff, which is available or was available from RS Components, and it's hideous. It comes with a cancer warning, so you use this stuff very lightly. The best way to apply it is with this little bottle I'll show you in a second, with a syringe tip. You put some in a bottle with a syringe tip, and you literally just squeeze it on the joint between the two pieces, and it gets drawn in and fills the gap. This is the following day, and as you can probably see, it bloomed a little bit on the corner there. So I had to chop the excess off anyway. So that gets rid of most of it. And the rest of it is easily polished off with a bit of Brasso. It takes a while. I've found over the years again that Brasso, I used to make stuff out of acrylic for my business, so you get quite used to what materials you can and can't use. And that cover strip also covered up the hole for the handle, so I had to re-counterbore it. There we go. Just checking. Ah, spot on. Well, close enough for me. There you go. Refit the handle with their spacers. And we'll go and try that on the machine, I think. Right, so here we are over at the machine, and I do like those black borders. I think they look really quite swish. The problem is that the bottom edge of these doors, there's no support, so they can flap around in the breeze. So it made sense to add something to stiffen them up to make them so they don't vibrate loose. So I found these acrylic sleeves, added an O-ring and used them, as you'll see in a second. This is what I've done. I've used a spare piece of acrylic of the right thickness to get the distance away from the threshold that way. I've then marked the position roughly of where these little rollers are going to go, and I've used a drill to just position the screw in the right place. So hopefully, just screwing this in, it's a bit wibbly wobbly. I don't know. I'll try this, because what I might do is, if they don't fit particularly well, I'll turn up some that have the right diameter to fit these screws. Anyway, let me do the other one, and then we'll try the doors. As you can probably see, these doors are now quite stiff, and they're locked in position, so they're not going to vibrate loose, and no coolant's going to come out from underneath. Around the back of the control panel, where the cables go into my support steel column, I don't know what you call it, there was a hole at the top, so I 3D printed this little spacer block, or cover if you like, to cover up that ugly hole. It should have been chamfered so that it was at the same angle as the cabinet, but I got that wrong. You don't tell anybody, I won't tell anybody. Right, moving along. This is a piece of stainless steel that came off the bottom of a door when they replaced a door at one of my old places of work, and I was given the stainless, and it's unbelievably tough, this stuff. So I scored the back of it, and which I did off camera, and as you can see, it's a fair bit of effort required just to push it over and bend it. What are the chances of me regretting this? I'm going to drill holes into the machine. At the top of this mill there was always a little cavity, and it was constantly getting full of chips and rubbish, so this little stainless plate is there to basically just deflect the chips and stop it building up. And then I move on. This is I decided I was going to use some neoprene sheet to protect the ways and keep as much of the chips and coolant out of the actual dovetails and ball screws and stuff. So this is a piece of quite soft aluminium, but machines up nicely, and as you can see, I've got a little clamp strip here. I just open the holes up in the main plate, and that thin strip you saw earlier just clamps against this and protects it. And while I was doing that, just look at the state of that limit switch. That's horrific, utterly horrific. So here we go. That's the top plate you've just seen me work on. That fits there. I then have to cut out another one for the bottom edge, which goes behind the travel casting, if that's the right word. Not really sure, but a little bit of linishing just to polish up the edge, and then we start cleaning out the crap that's in this limit switch. I'm amazed that it still worked. Just how appalling is that? It's just utterly caked in crap. Yeah, foul thing. I've been cleaning the switch out, the limit switch, and I was just going to test fit it back in, and I'll just show you this. I don't know if you can see this, but they had 2 attempts at drilling the holes, and the reason being there's a broken off tap in that hole. So I'm not going to get that out, so I'll just have to grind it flat, I think. How typical is that? I don't know if you can see this particularly well, but they ground away part of the top of the of its case. So how on earth they expected that to seal and stop the smooth from getting in, I don't know. I never noticed that before. Don't know what I'm going to do about it either. Before you all jump on your keyboards, I know I was grinding on the actual mill, and I shouldn't. What I don't show you is the fact that it had a damn good clean out afterwards. All the ball screws needed a really good scrub, so all that was done off camera. So it was cleaned out, I promise. And here we are. This is the neoprene I bought. It's I think it's about 1.5 mil, maybe 2 mil thick. And you can see the plates I made have now been painted to give them a nice patina. And yeah, that looks really quite good. So here we go. We just bolt it to the machine, and then I'll test it in a few seconds, as you'll see. And I was really quite impressed. It does seem to do the job really quite nicely. It keeps all of the rubbish, coolant, chips, broken tools from going down the back of the machine and getting lost. Also, just for completeness, added another one on the front here, and there's nothing to support the front edge of this. It literally just wraps down the front of the machine, and oddly enough, moving the table backwards and forwards is enough to push it in and out. It doesn't need any other support. So moving on yet again, I decided that I can do better with the labelling on this control panel, and as recently I bought a little printer, I thought, yeah, I'll change that. I'm really quite chuffed with those. That again doesn't look too bad. So after cleaning out the limit switch, here we are back on the bench. This is that's the Y limit switch that screws to that sub plate. That one was actually quite clean when I took it to pieces, but I've replaced the flexible conduit. There you go. That fits under the table, which is why I suspect it's quite clean. There we go. Back in the machine, I can work out the length of the conduit I need and just chop it off. There we go. And I decided in the end that I would use XLRs for these signals. It is literally only just a normally open contact for the limit switch, and these XLRs are a good choice. They lock in so they don't fall out, and they're perfectly suitable for that. And here we go. This is the last piece of conduit that needs to be replaced. That is the stepper drive for the X-axis. There you are. You can see that these XLRs lock in quite nicely. They're 5 pins, so that I can do. There's a possibility of future expansion should I need to. And I also decided that I was going to use XLRs for the 4th axis and the X-axis. However, I decided that these connectors that came with the machine can carry more current, so I'd stick with them for the time being. And I've got enough spare parts now to actually replace the 2 that are broken. So there we go. That's the X-axis shroud that goes over the stepper, and as you'll see, it goes back on the machine. Thread the wires all the way through. There's only 4 wires for a stepper. Put it in place, feed the conduit through the back, and replace the connector. Not a particularly difficult job, just time consuming really. Oh, and finally we get to fill up the oil tank. I finally decided that rather than use old engine oil, I know, shoot me, I decided to use proper slideway oil. So here we are. I'm about to do some testing. I needed to fill it up, and so I thought I'm just going to use plain water to start with. I know there are issues with that, but I did give it a damn good clean afterwards, and if I needed to do any repairs, it's far easier to do it with clean water rather than water with oil in it, because I can don't don't have to clean all the oil off. So I changed the tool to one that's going to throw the water about, and fire the old girl up and spray the water everywhere to see what leaks and where it leaks. Nothing came out the top, which is good, because the head's at its highest point in this test. Side windows work perfectly. Really chuffed with that. I left a bit of tape on by accident. Take that off later. Nothing coming out of the conduit holes. The oil feed is clean. No water coming through there. There was some coming through here, and that's because the head is at the top of its travel. And realistically, that's not going to happen that often unless you've got a really tall part in. So I don't really see that as being a major issue. Right, and down the side here and the bottom, you can see the little dam that I welded in last time on at the back of the steel support for the mill, and there is a little bit of water coming through there. However, it only happened this once, and it's been a week or so, and I've used the mill a few times recently, and it was only there the once, and I think it was because I was using the hose pipe to fill the tank up from inside. I think I literally forced the water through and into the back, but those little wells there are working quite well, if you pardon the pun. Over on this side, dabble my finger in and you can see that yeah, it's damp. Perfect, it's just what you want. I did have a leak. This is the major leak. It's coming through the front, and that's basically because I didn't seal that front bar. So here we go, a little bit of silicone on the job, and you'll see me screw it back on in a second, and that cured that. I was really quite chuffed, to be perfectly honest. That was the only real leak that I had in the whole thing, and that was because I'd forgotten to put the silicone in. Right, we'll have a little look at the chip tray, and yeah, indeed, it's catching the chips. That's got to be good. I thought I'll put some oil in it now, and I thought, actually, no, I won't do it there. I'll do it inside. Just dribble it down the inside of the casing, and there you can see it finding its way to the water. I then ran the machine for some time to get that fully mixed in, and here we go. We're pretty much done. Just push it back into its into what will be its new home, and as you'll see in a minute, it's difficult to work out exactly where I'm going to leave it, but I need enough space to get the doors open. There you go. If you can't get the doors open, then there's no point in putting it there. So there we go. That is it. Pretty much done. I am chuffed to bits, to be perfectly honest. It really has worked quite well. And the X-axis limit switch, I did a temporary installation with it, and I'm cutting out a box here for a replacement case for it, and as you can see, it's all working really quite nicely. There are some mods I'm going to do. I'm going to increase the height of the chip tray because there's a little bit of spatter coming out over the top, and the washdown pump is nowhere near big enough, so I've got another one on the way which I will replace off camera probably. This is one of the problems with where I live. Aircraft noise. Every day they go round and round and round. I mean, listen, would you want to live with that? Now the jet has gone off to bother somebody else, you can see this is finished. I am really, really stoked. I think it's come out really, really well, and remains to be seen just how reliable it is. Like I just said, I'm going to make some changes. I'm in the process of changing the X-axis switch so that it doesn't get full of schmoo like it did before. Also, down at the bottom, I don't know if you can quite see that, but the chip tray needs to be a bit taller because the coolant splashing into it splashes out over the sides, and that will not do the wood in there any good, and eventually the floor here is going to get greasy and slippery, so I'll change that. The rest of it, I can't think of anything that I need to change at the moment. It doesn't leak. It looks absolutely fantastic. The yeah, the interior I think is going to be fine. I was a little bit concerned with using glass fibre, and it may still be a problem if you're machining dry and the chips are coming off red hot. Then they could melt their way into the surface of the glass fibre. But yeah, realistically, while I've got coolant, I'm going to use coolant, so I don't think that's going to be a major problem. Oh, and the other thing I should mention is the washdown pump. Yeah, I'll see if I can turn it on. Ooh. That's not much of a washdown. Whoops. I can wee harder than that. So I've got a much bigger pump on the way. Yeah. Turn that off. Yeah, I think, I don't know what I was thinking. On paper, that should be a big enough pump to do the job. In practice, yeah, nowhere near. Anyway, thanks for watching. Apologies once more for not recording any audio on this video. There were bits and pieces that you did hear, pieces of the camera, and they were done on my little GoPro. But my main camera, my SLR, I still can't believe I did that. Anyway, thanks for watching. Do hit the like and subscribe button, and hopefully we'll see you on the next one when we use this, or possibly one of the other machines, and we'll move on. We'll do something new. That's a promise. Do something new. Yep, definitely do something new. Or should I revisit something? I don't know.